All right. So last video we discussed limits at infinity and infinite limits rather. This session we're gonna discuss what happens if we take a certain function, let's say f of x equal to 1 over, let's say x. Right? Let's take this function and we're finding the limit as x approaches infinity of 1 over x. Okay, so uh, this means conceptually what happens if you substitute a big positive number, right? So if we say that x approaches infinity, that means that x becomes larger and larger and larger as we can. Now we can do a table of values, but let's just try it out. So if x is say 1 billion, right? If x is 1 billion, what does f of x become? Notice that uh, it becomes 1 with 8 zeros, right? And if we keep on increasing this number, what happens to the value of f? This becomes smaller and smaller and smaller until, so if this becomes infinity, so this becomes larger and larger and larger, this one here becomes 0, right? Closer and closer to 0. And notice that for limits at infinity, we're not saying infinity from the left or infinity from the right because that doesn't make sense, right? So in here, we just say, and it's equal to 0. All right. Uh, Another question would be for the same problem, what would be the limit? Okay, the limit as x approaches negative infinity of 1 over x. All right. So meaning, what happens if you substitute a big negative number? Okay. Now, all right. For this one, for completeness sake, let's do a table, and let's consider big, very big numbers. Let's say a very big negative numbers. So negative 1 trillion, for example. What will we get? It's a negative 0.0001, negative 1 quadrillion. We get I'm not sure, right? And if we have another negative number here, we see that this is becoming smaller and smaller. But the tendency is this is becoming approaching negative infinity, right? But this is still approaching 0, right? It's becoming smaller and smaller. They're negative numbers, but what you're seeing is it's approaching 0 from the left. Okay, so we then say that the limit of 1 over x as x approaches negative infinity is equal to 0. All right. So it's slightly different from the first discussion of infinite limits, where the answer is infinity. For this question on limits at infinity, we're now wondering what happens if where we're going to is infinity. Okay? Now, let me tell you some facts. All right. Usually for items like this, for limits at infinity, what you're gonna look at, we will consider rational functions. Meaning functions that look like this: 2x squared plus 3x cubed plus 4x to the fourth over 3x squared plus 4x cubed plus 5x to the fourth. Okay? These are the types of functions that we're going to look at. It's a polynomial, which is a polynomial over a polynomial. Okay? Now, there are, so for this case, then, there are three possibilities. Okay? All right. The first possibility is, so you have a numerator, let's abbreviate as num, over the denominator. Okay, so the numerator is on top, denominator on the bottom. Case one, the denominator is larger. Okay, meaning the limit will look like this. For example, x squared plus 1 over x cubed plus 1. Right? In this particular case, we see that the numerator is a squared, the denominator is a cube. Okay? So when we say larger, we mean higher degree. Okay? Now, if the denominator is larger, that means the denominator is growing faster, which means that this would be equal to 0. So if the denominator is larger, the limit is always 0. Okay? Regardless of whether it's positive or negative infinity. If I wrote it like this, right, like that, then it would technically be negative 0, but in any case, it's still 0. So if if the denominator has a higher degree than the numerator, the limit at infinity is 0, which makes sense. Okay, you can kind of think of it as the denominator is growing faster than the numerator, right? Okay, now the second case is, what if the numerator is larger? Okay, what if the numerator is larger? So for example, uh, limit as x approaches infinity of, say, x cubed plus 1 over x squared plus 1. All right. Now, notice that the numerator is larger than the denominator. The one on top is larger than the one on the bottom. And what does it mean? That means this will just be either. So it's either, if the numerator is larger, it's either positive infinity or negative infinity. Because there's nothing that will stop the numerator from becoming larger and larger. Okay? Now, for this particular case, then, this would become is infinity, right? Your decision now is whether it's positive or negative. How do you know? If it's positive infinity, right? So you substitute a positive number. So let's say substitute 1, right? Or substitute a large positive number. Okay. Then look at the sign. In this case, this limit here is positive infinity. On the other hand, the limit as x approaches negative infinity of the same function. So this is still infinity because the numerator is larger, but is it positive or negative? Let's see. It's a negative number, so the denominator here becomes negative. Actually, you're just gonna look at this, by the way. You're just gonna look at the largest powers. You're just gonna look at this. Focus on this. Disregard the other uh, terms because this will dominate as x becomes larger and larger. So in here, the denominator is gonna be x squared. So if we substitute a negative number and it's squared, so it's positive. In here, x cubed, if we substitute a negative number and we cube it, it's negative. So it's negative over positive. This is negative. Okay. Another example would be limit as x approaches negative infinity of x to the 7th plus x to the 6th plus x to the 5, okay, over x to the 5 plus x to the 4th plus x cubed. For example, that is an example. Plus 1. Okay, let's add something like that. Now, notice again, you're going to look at the highest degree. In this case, the numerator's highest degree is 7. The denominator's highest degree is 5. Therefore, the numerator grows faster than the denominator. Now, you have made that decision. So it's either is infinity, right? Is it positive or negative? Now, you're just going to focus at the largest exponents. You're just going to focus at this and this. If you substitute a negative number to the 7th power, you get a negative number. If you substitute a negative number to the 5th power, you also get a negative number. Then negative over negative, hopefully everyone's fine. Negative over negative, this is positive, right? So that's the second case, right? Where the numerator is larger. And the third and last case is, what if the numerator and denominator have same degrees? Meaning something like this. Limit as x approaches infinity of 4x cubed plus 3x squared plus 1 all over 6x cubed plus 3x squared plus 1. Something like that. Notice that they're the same. They're both to the 3rd power. So the shortcut here is just look at the coefficients. And it's just going to be that 4/6. It's just 2/3. Okay. This is also the same if it's negative infinity. Let's say 4x cubed plus 3x squared plus 1 all over 6x cubed plus 3x squared plus 1. If it's negative infinity, it doesn't really matter if it's positive or negative. You're just going to look at these. Okay. The ones with the highest exponents. Then you look at their coefficients. It's going to be that 4/6, which is equal to 2/3. So in essence, what we have in here are three cases. First case is if the denominator is larger. The second case is if the numerator is larger. And the third and final case is if the numerator and denominator have the same degrees. All right? So let's try some problems here. Let's try this. So we're trying to find the limit as x approaches infinity of 4x plus 7 over 5x minus 9. Okay? Now, notice that they're both linear. The exponents of x's are the same. This is 1, this is 1. So we do the shortcut. This should be equal to 4/5. Okay? 4/5. Right? Similarly, so same function, but this time x approaches negative infinity. And as we learned, it doesn't matter. It's still the coefficient of the highest degree, which is 4/5. Okay? That's it. Okay? Now, now, let me tell you then of the concept of horizontal asymptotes. So during the last video, we discussed what a vertical asymptote is. This time, let's discuss what a horizontal asymptote is. So a number y equals a is a horizontal asymptote if the limit as x approaches infinity of f of x is equal to a, or the limit as x approaches negative infinity f of x is equal to a. So in essence, what the horizontal asymptote is the limit itself as x approaches infinity or negative infinity. So for this particular case, we say that y is equal to 4/5 is a horizontal asymptote to the function, to 4x plus 7 all over 5x minus 9. Okay? We say that y equals 4/5 is the horizontal asymptote to 4x plus 7 over 5x minus 9. Similar to here, we say that y equals 2/3 is a horizontal asymptote to 4x cubed plus 3x squared plus 1 all over 6x cubed plus 3x squared plus 1. Okay? And this, right? So in this particular case, the horizontal asymptote is y equals 0, or the x-axis. Okay, So when a problem asks you to find all hot asymptotes, so not only the vertical but also the uh what do you call that? The or not only the vertical but also the horizontal. All right, this one right here. So yeah, for this particular example, the limit as x approaches negative infinity of 5x squared plus 11 over 7x minus 2. Okay, this is the first time I'm saying. Pause the video if you want to try it out. I will say the solution in 3, 2, 1. All right. Now, the exponent in the numerator is larger than the denominator. This is squared, this is the first. So meaning the numerator is becoming uh, is larger. So numerator is larger. So you're deciding whether it's infinity or negative infinity. So is it positive or negative? So in here, 5x squared, x approaches negative infinity. So if you square a negative number, you get positive. So the numerator is positive. The denominator, 7x. 7 times negative number, because it's negative infinity. So this should be negative. Positive over negative. Therefore, this becomes is negative infinity. Right? Letter C. In here, okay, copy it first. The limit as x approaches infinity of 7x to the fourth minus 14x squared all over 6x to the 5 plus 7. 3, 2, 1. All right. We see here that the denominator is larger than the numerator. Denominator has degree 5, the numerator has degree 4. The conclusion is this has an answer of 0. Okay? All right. Since denominator is larger than the numerator. Right? Makes sense? And finally, this one right here. Let's try to find all the asymptotes of this function right here. 2x squared plus 3x minus 2 all over x squared minus x minus 2. All right. So there are only two classes of asymptotes. So you have the horizontal asymptote and the vertical asymptote. You only have those two. Now, let's try to solve first the horizontal asymptote because this is fresh in our minds. How do we solve for the horizontal asymptote? We find the limit as x approaches infinity or negative infinity. Okay. But in this case, let's have negative infinity. Let's use positive infinity of the function at hand. Okay. Now, both are the same, squared, squared. So you're just gonna look at the coefficient of the highest exponent. In which case, this is 2 and this is 1. There's a 1 there. It's not 0, huh? So the final limit is 2 over 1, or it's just 2. Therefore, therefore, y equals to is a horizontal. Makes sense. Makes sense so far. Now, how about the vertical asymptotes? This is a little bit different. And if you recall the last video, we need to find we need to find all values of x that will make only the numerator, only the denominator zero. Okay. So in this particular case, we will rewrite 2x squared plus 3x minus 2 all over x squared minus x minus 2, right? You can use your calculator to solve for what x is here. So you need to equate the numerator. Okay. So to do that, equate both numerator and denominator zero. Okay. You need to equate both. So at the very end of the day, this will become, well, if we factor this out, this is 2x minus 1, x plus 2. This is x minus 2, x plus 1. Right. So that means that the numbers that will make the numerator 0 is 1/2 and -2. Okay. So we equate both of these to 0. The denominator, we equate to 0 as well. So x minus 2 equals 0, x plus 2, x plus 1 equals 0, x equals -1. Are any of these common? No, right? So what are the values of x that will only make the denominator 0? The answer is 2 and -1. So the final answer is x equals 2 and x equals -1 are vertical asymptotes. Okay. So for this video, we discussed limits at infinity, how to get the asymptotes of a function. And for the next meeting, we're going to discuss something different. We're now going to start discussing derivatives. Answer the quiz. Good luck and God bless.